Alright, welcome back to another book reading video. One thing I've been thinking is, since I'm so new to some of the concepts in this book, I might want to go and just type it out. Well, I mean, I'm not new to regular expressions, but I think I'm going to go back and well, no, you know what? I'm not going to go back because it's just too. I just want to get through. I want to get to the actual network engineering part. Okay, so this is IPython Features. You saw some of IPython's features at the beginning of the chapter. Now let's look at some more advanced features, such as running shell commands from within the IPython interpreter and using magic functions. So I will get IPython up. Okay. All right. Using IPython to run Unix shell commands. You can use IPython to run shell commands. This is one of the most compelling reasons to perform DevOps actions in the IPython shell. Let's take a look at a very simple example where the exclamation point character, which IPython uses to identify shell commands, is put in front of the command ls. Oh, that's nice. So I'm running this on Windows, so if I do that, it probably won't. Yeah, it doesn't work. I have to use the Windows version, which is dir. I didn't know you could do that. That is one of the most amazing things I have learned in a while, because that is cool. Okay, but let's from now on follow along with the examples, type them out the way they are. Oh, and we'll do dir instead because I can't use that. So let's do a type. Okay, so now we've got an object, IPython object. And did I move my? Okay, let me move my bookmark as well. Okay, so we got the same thing they got. The output of the command is assigned to a Python variable, var_ls. The type of this variable is ipython.utls.txt.slist. The slist type converts a regular shell command into an object that has three main methods: fields, grep, and sort. Here is an example in action using the Unix df command. The sort command can interpret the white space from this Unix command and then sort the third column by size. So let's follow along. So I'm gonna abandon this. Let's see if I can get a PWD. No, I can't. So let's find a way to navigate to this in a shell that allows for Python command, in a shell that allows for Linux commands. Okay, so I've got a git bash shell here, so I just need to change directory to where I was before. There we go. And now I can do a source VNV bin, or scripts still activate. Okay. Oh, and I'm going to start IPython. Okay, and now I can follow along with exactly what is written on the screen. So, yep, we're going to do df equals exclamation point df.sort 3 nums equals true. There we go. So, I was just this 93%. I used to have problems where I was running out of disk space, but I found I had some things on there that I could get rid of, so I thought I didn't have that problem where I was trying to conserve disk space anymore. So this kind of was a surprise to me because I thought, oh, like, am I running out of disk space again? But I think this is just for, this is just specific to a folder. It's not my whole system. Let's take a look at slist and .grep next. Here is an example that searches for what commands with kill as part of their names are installed in the /user/bin directory. Yeah, and for anyone learning Python new, this is definitely going to be confusing because we've got spaces here in our definition of a variable, which is something you normally can't do. But it's because we're in IPython here. We're still in Python. I mean, we can see we're still doing Python, but we're in a special shell named IPython that allows for this sort of thing here because of this exclamation point at the beginning. There we go. All right, the key takeaway here is that IPython is a dream environment for hacking around with little shell scripts. Yeah, that is definitely the key takeaway. I use IPython whenever I use a Python interpreter shell. But there's definitely a lot more I have to learn about it, such as using IPython magic commands. If you get in the habit of using IPython, you should also get in the habit of using built-in magic commands, and that's something I don't do. They are essentially shortcuts that pack a big punch. Magic commands are indicated by prepending them with 2% signs. Here is an example of how to write inline bash inside of IPython. Note this is just a small command, but it could be an entire bash script. So now that I've got this, I've got my own bash shell here. Oops, something happened. I don't know what happened. But a bash command would be uname-a. So all I need to do is do bash like this, and now I can enter in uname-a because it's a valid. I guess I'm a little bit lost here. Let's see what the book has to say. Oh, okay. Well, the book, okay. Let me try this again. So, bash uname-a. Nothing. Let me see if uname-a is a valid bash command on here. Okay, it is. So I don't know why it's acting strange. Maybe because it's a Windows environment. It's probably because it's a Windows machine and then using a bash emulator. So that's probably why it's going wrong for me. The %write file is pretty tricky because you can write and test Python or shell scripts on the fly using IPython to execute them. Oh, that's not a bad party trick at all. That's awesome. Cool. So once you're playing around in your shell, and you've got your you're doing whatever you want. So I want equals variable. Once you've got everything all hashed out the way you want it, you can keep your shell open. You don't have to close your shell. You don't have to switch to anywhere else. And then you can copy it like this, and then do a magic method called write file, and then give it the file name, and then just paste it right into the shell. There you go, and you can preserve your code without even leaving your shell. That is cool. I didn't know you could do that. So you can see they're using a more, yep, and then they're catting out. We can do that with the one I made. It was called example.py. So, but the thing is, you can just use a exclamation point like this and do cat example.py. There we go, and print it out right from the shell. It looks like they don't have the exclamation point here. I think that's like a typo or something. I'm not sure what's going on. But let's keep going. Another very useful command, %who, will show you what is loaded into memory. It comes in quite handy when you have been working in a terminal that has been running for a long time. So this is kind of the equivalent of the dir command in Python, but it looks like it gives you a lot neater output. And I do see something interesting here. It looks like they only have one %sign. Let's try it. Okay, 1% sign works. I thought you needed 2% signs. I guess I'm confused about that. But it looks like in this case, oh, okay. So it looks like 2% signs is cell magic, but 1% sign is line magic. I guess I'm not sure what that means, but it looks like if you, but this usage error message here makes it really nice and clear. It's just 1% sign that's needed, and then you get this same thing you would get here, but you get more relevant information, and it's a lot cleaner. All right, let's do the exercises. We'll write a Python function that takes a name as an argument and prints that's name. So def exercise name, and then we'll do print name. Oops. Okay, so let's try running the function. There we go. Next exercise, write a Python function that takes a string as an argument and prints whether it is upper or lowercase. Okay, so we can just redefine the function. Oh, I don't know why. Oh, okay. I'm gonna get out of this terminal and open up. Yeah, because this is not an emulated terminal, so it's a little bit better. I think it'll preserve the formatting where the other one would just throw it away. Okay. All right, so this is going to be a better terminal. It's going to preserve the formatting and colorization if there's any of that. So let's write a function that takes a string as a parameter. So we already know what to do. We're going to do def example, and then we'll say input. Okay, and your input is going to be a string. So now we're going to print out whether that string is upper or lowercase. Okay. So we'll say so this is where that help is really important. I can do help str, and now I can look at all of the tools in here that will allow me to do that. So here we go. So here's the is. So we've got is upper and is lower. I bet you are valid ones. Let's just try it. So we'll do test dot is lower. There we go. And now let's do is upper. Okay, perfect. And now let's try this. Test is upper, false. Test is lower, false. Okay, so here's the function we're going to write. Example, input, if input dot is upper, we're gonna return your, and we'll do this instead of print so that it can be saved into a variable. So we're gonna say your string is all upper case. Okay, and then we'll do an elif input dot is lower, return your string is all lowercase. Okay, and then we'll do one more conditional here. So we'll do else. So anything else, we'll say return your string is either your string is not all uppercase nor all lowercase. Okay. All right, so let's test this out. Example, test with all lowercase, strings all lowercase. Let's try it with test all uppercase, strings all uppercase. Let's try it with the combination of cases. It's neither all uppercase nor all lowercase. Let's try it with something that's not a string. Let's try it with a list. List object has no attribute is upper, so you've got to pass it in the correct kind of input that it expects. And this is where those doc strings are so important, and we'll go over that. So if I add another line and then I add a doc string here and say you must enter a string as an argument. Now, if I were to go and run this, and I can do page up to not have to do that. There we go. And provided a list and say, oh, what happened? You know, I thought I could run it with a list. Well, let's take a look at the help. And we can see now, you must enter a string as an argument in the help because I included this doc string here. So we can see just how important that help function is, just how important those doc strings are. Otherwise, you could have a function that you just don't know what to provide the function unless you can see the source code of the function. So really important to have those doc strings. I'm definitely guilty of not having those in there sometimes. Especially if you're kind of coding for emergency reasons, not having a doc string is sometimes something I do, but I would not say at this point that I'm a super high level Python coder. I'm trying to get better. That's part of what I'm doing here. So one way I think I can get better is to always use a docstring if I'm using a function. Sometimes I do not do that. All right, so the next exercise is to write a list comprehension that results in a list of every letter in the word SMOG, in this word, capitalized. Okay, so I can do that too. List comprehensions I'm a little bit more shaky on, but I believe it would just be letter for letter in SMOG TETHER. But we're not going to just have letter for every letter in there. We're going to have letter dot upper. And there we go. That's it. So we got a list, and we've got every character in this string in uppercase. All right, next exercise, write a generator. Oh my God. That alternates between returning even and odd. So this is where I think I can do this. Let me see here. So it's got to be a function. If a generator is a function, like to write a generator, you have to write a function. So let's do that. We'll call it def. We'll call it alt. And now it's going to take even or odd. Oh, actually no, it's not going to take any input. All it's going to do is alternate between returning even and odd, starting with even. So we'll do yield even. And then unfortunately, here's where my knowledge breaks down. If I hit enter, yeah, first of all, I've got invalid syntax. Okay, so I've got valid syntax now. But let's try finding the answer without leaving the terminal. Okay, so already I can't do that, so let's make sure I've got this bookmarked. Oops, and I skipped around. I'm not sure what happened here. There we go. So, oops, and I got this last one. Let's go back and do the example on generators. Okay, so here's here's a generator comprehension. Okay, so one way we can do it is we can do a generator comprehension. So we can say we're going to print well, let's is that all we got on generators? Oh, that's for generator comprehensions. Oh, okay. Here's generators. So yeah, let's write this out here. And if I come up with my answer, we'll just move on as soon as I come up with it. So let's just do the examples here. This is def count, n equals 0, while true, n plus equals 1, yield n. Let's try running it. Okay, so we've got a generator object when we run that. So let's see what we get for help on that. We don't get anything. Oh, we want help on the generator object. So on the invoked function is what we need help because it returns a generator object. So when we invoke the function, we'll get help on a generator object. Okay, so we can do send, we can do throw, we can do close. Let's see what the book does. Okay, so we're going to say counter equals count, because we can see if we run count, we get a generator object. So let's save that generator object into a variable named counter. Okay, and now let's do a help on counter. And you can see one of the things we can do on counter is next. So implement next self. That's something we can do. And we can do that because that's a method it has. All right, so next counter. There you go. And we keep doing that. We're going to go every time we run it, we'll be incrementing through it. So note that the generator keeps track of its state, and hence the variable n in each set call to the generator reflects the value previously set. Okay, that's actually really useful. Like this, basically I need a generator because like one of the things I need to do more is like take better like statistics on my like how many times have it run, because I need to be able to like talk more about like the value that a script I write provides. So like I think this generator function can like count up how many times it's been used, and I think I need to get used to using generator functions. Okay, so let's try to write one that flips between even and odd. So we're gonna def my generator. Okay, and then we'll say okay, we'll say n equals 0, and then while true, n plus equals 1, and then we'll do if n divided by 2 doesn't have a remainder. So we'll do modulus 2. So when it's divided by 2, it doesn't have a equals 0. There's no remainder. That means it's an odd number. Sorry, an even number. So we will print even. Okay, but if n divided by 2 does have a remainder, or we'll just do an else, then we will print odd. Alright, so this is one way to do it, probably not the best way to do it, but let's see if it works. Pint, I gotta do print. Okay, so that obviously didn't work at all. Oh, right, because I used print, not yield. There we go. That didn't work either. Let's try this. Why is that valid syntax? Oh, I spelled it wrong. It was probably fine though. See, this is where your code kind of gets messed up, is you have a, the top one was wrong too. See, I can go back to the one I had before. That was perfectly fine. Yeah, I just misspelled yield. It's IE. There we go. Okay, so now let's save it. So we're going to call it gen equals my generator, and we'll do next gen. There we go, and now it saves the state. Looks like it started with odd instead of even, but that's just a matter of changing it here. There we go, and now if I redefine my generator and keep hitting this next, now we can see it starts with even, and it flips back and forth between odd and even afterwards, just as was the goal for this exercise, which is the last exercise in chapter 1, and thus marks the end of chapter 1. So chapter 2 is automating files and the file system. I think I'm going to end the video here. It's been about a half an hour because I want to close out chapter 1 and make a new title for chapter 2.